Okay. Let's see. We are back and good to go. We have our first subscriber. I can't believe it. I'm going nuts. But I wish I was there when they subscribed. I wish I could have thanked them in person. It's okay though. Let's see. Seem to be getting a lot of delay on my worksheet here. Takes a lot of processing power. Okay. First things first. What would be a good idea to start with? Solving equations. One-step equations. Grade 9. This segment is the grade 9 hour till 8 o'clock. Okay. If I had the better setup, it'd be nice, but okay. In grade 9, this textbook, starting with chapter 2, well, patterns and equations. So what do they want to do? Look for patterns, simplify some mental math. Identify some patterns. So what's the pattern in this sequence of numbers? And without doing inspection, without even looking at it and being like, oh, I know what it is. What is the next two numbers? Well, we could start by finding the difference between the numbers. So 8 minus 5, is it equal to 11 minus 8? There's one way I would think about doing it. 8 minus 5 is 3. 11 minus 8 is 3, so it goes up by 3. What about the next one? 11 and 14. Well, up by 3. So, let's see, a plus 3. Plus 3, plus 3, plus 3. 14 plus 3 is 17. So we've got 17 and then 20. Okay. Another pattern. A little more complicated. 10, 12, 9, 11. I can't believe I wrote 3. Different thinking here. 11, 8, 10, 7. What are the next 2 numbers? I'm just going to read blanks. Okay, well, from 10 to 12 is plus 2. From 12 to 9 is minus 3. From 9 to 11 is plus 2. From 11 to 8 is minus 3. Plus 2. Minus 3. Plus 2. 7 plus 2 is 9. And then this one should be a minus 3 to keep up with the pattern, so this one should be 6. Let's see. Let's look at some of these other problems here. This is still just dealing with patterns. So, eight people entered a tennis court. Each person played everyone else once. How many games were played? Now this is in patterns. Interesting. How would we do this with patterns instead of probability ways or statistical ways? Well, let's see. How would I write this? I wonder, how would I write it? Let's see. Well, the first person will play 7 games against each. How many ways can we have 8 people play games? How many matches? Well, 8 divided by 2, because there's 2 people a match, would be 4. times 7 number of matches per person, which would be 28 matches. Now the question is, how do you write it as a pattern? Would you write it as 7 for the first match, plus 7 for the second, plus 7 for the third, plus 7 for the fourth? Maybe. And the rest of these are a little less interesting. Evaluating expressions. Okay, this one's a base set now. Evaluating expressions for like a grade 9 level. Okay. It could be, yeah. Robbie, how you doing, bud? Why does that feels bad, man? Which is good. I mean, you could be doing entertaining things. Oh, Robbie, since you're here, you and I can work on something a little interesting. There's no point in me doing grade 9 stuff. Okay. What was it? Oh no, I didn't write it down, or did I? Yeah. Robbie. Log 2 of root x plus 1 equals log of 3x. What is x? I'm getting these interesting questions sent to me. And some of them take quite a while to figure out, like, a way to describe them. So I figured it'd be good to do this one on stream. Because then you can tell me what I'm doing wrong. Yeah, there is a base conversion. So log of base bx is log with the base that you choose. So let's just leave it with 10. X is log of b. So if we do, let's say, base 10, this would be log of root x plus 1 over log of 2 equals log of x log of 3. Now I'm going to tell you something. I know that the answer is 9. But I only know it by inspection. I haven't been able to quite figure out how to show it yet. I've reached a little standstill. Log of log rule. Okay, well the other log rules. So like I'm just gonna use natural log so I don't have to write so much. A times b is natural log of a plus natural log of b. Natural log of a divided by b. Natural log of a minus natural log of b. Now, the funny thing is, I haven't seen any product of logs, especially since log of 3, let's say, is a constant, right? They're a constant. Like, I'll show you what I ended up coming down to think about. I was thinking log of root x plus 1 equals log of 2 over 3, right? And then I'll just say some constant is log of 2, log of 3. I only do that just to make it easier for writing. And then I would think, oh, well, log of root x plus 1 is equal to some constant log of x. And then there's that exponent rule. So some constant log of x is equal to log of x to the exponent, right? I should actually write a little slower so it's a little nicer, neater. And then what does that give us? Exactly, right? So we've got square root of x plus 1 is equal to x to the c. It is? I don't know. I feel like, so my Instagram is interesting because I'm getting quite a few people from all over the world recently sending me problems. One of them from a country that's near Turkey, and he's a teacher that wants to get better at math, and he wants to do Olympiad math problems. And so he sent me a few of them. I'm not really sure. What is that one? I don't know emotions. PogChamp? Okay. Log 3, log 2. Yeah, International Math Olympiad. I don't know. I find it interesting that they're sending them to me. It takes a while to solve them if you don't know the answer right away. Like, there was one that I did that was 3 pages long on the Instagram. But then you can do it another way and it's like 3 lines. So how would we solve this problem? How would we find a solution to this? Some constant that's just absurd. I was thinking about having different bases that were a little bit more interesting. So like log of 3 I want to change the base to log base 3 of 3 over log base 3. Wait, what am I doing again? I'm screwing up my own formulas here. Oh, right. Log base 3 of 3 over log of 10. But I'd go back to the original. Instead of doing bases of 10 for the original problem, I was thinking about changing them to base 2 and 3. Or one of them to be the same. So instead of being 2 and 3, maybe just leave it as both 3. So log base 3, 3 and 2, right? Yeah. But it doesn't give us anything too relevant to finish solving the problem, right? But, you know, let's play with it. Log base 3 root x plus 1 equals log 3x. And then this is multiplied by the constant log base 3, 2. Yeah, there is only one solution. Like, even if you graph the two, there's the one intersection. We know it's 9 just by looking at it and inspecting, but, like, how would you show that it's 9? How would we get it down to being ... x equals 9? That's the one thing that I wonder. The funny thing is, you can type in these functions into those solvers online. They'll all give you 9. They'll all give you the right answer, but they'll say there are no steps. They'll say they do not exist at the moment. So another thing we could say is three, because 9 is 3 squared, right? I keep thinking in base 3s and 2 and seeing if I can get 9 out of it. If we raise everything to the power of, so 3 to the log of 3 root x plus 1, 3 to the x times, I should write this properly, log base 3x times log 3, 2. The only thing is when these are exponents, they're multiplied, they're not added, which is really unfortunate. So this is the same as saying to the power of, right? So then we'd get root x plus 1. We'd get x to the power of log 3, 2, which isn't any better, right? It's still the same thing. A little nicer to work with, but what do you think? I probably should have kept what I had written down. Oh, yeah. Then there was this idea that log b of x is equal to y, right? So then x is equal to b to the y. So then I wrote log 3 of 2 is equal to y. So then 3 to the power of y equals 2. So I have something similar like that. I'm not sure. Not sure. Mm-hmm. Yep, it does look similar. And then I kind of tried to work backwards. So I know x is 9, and then I was like, well, I know it has to be some value. So 9 is 3 squared, which is the same as, what is it, log 3 of 9. And I was doing like change of bases to get 2's in there and a whole bunch of stuff. Multiply by 2 on each side. Now, which side are you referring to? The original equation 1, or are you referring to the log? Where we started? So you're thinking, well, okay. Let's erase all this then. So are we talking like final results after base changes? So like right here. You know, this actually gives me a good idea. I should make sure to number each line so that way people can say which line I'm doing. So line 1, 2, 3, 4, 5. So which line are you referring to that you'd want to multiply by 2? Hmm. Yeah, I was thinking about squaring. I was thinking about squaring both sides to begin with, and then having a change in that regard, but it's still the same, isn't it? It's an interesting question. Copy it down. Think about it. Maybe you'll figure it out. You'll have a eureka moment. Uh, hey, Robbie, do you follow my Instagram here? Did you see the post that I had? What was it, this morning or yesterday? Let's take a look. Anyways. Nice, nice. You notice how it's 3 pages long? I think it's hilarious. The guy who sent it to me figured out a different way to do it, which was great. It's literally asking just if x minus 2 root 7 over root x is equal to 9, then what is x minus 7 root x? What's the answer to that? Well, you want to try it? The only thing is, you're right, we have 2 equations and technically 2 unknowns. If I say it's y. No, I can try it. And how come you're up so early? I'll tell you what I'm gonna what he kind of showed me, which is a little interesting. So, what if we take away? What if we turn the 9 into a what did he write in here? 7 plus 2. And we've got x minus 2 root 7 over root x equals to 7 plus 2. Then we take the 2 root over and we take the 7 over. So we've got x minus 7 equal to 2 plus 2 root 7 over x, root x. And then what if we go root x plus 7 times square root 7 times square root x minus root 7 as like the factoring. And we factor out on the right, we've got a 2, and we take out a root x. We should be left with root x plus root 7. Cross out both of those because you can divide by that. You've got root x minus root 7 equals to 2 over root x. And then you multiply by root x, which yields x minus square root of 7x is equal to 2. I thought that was way nicer than mine. Mine was just very rigorous. That was a neat one. Yeah, but yeah. So that's the thing. If they were really high, then it's more difficult. These were pretty small. But what did you think? What did you think of the way I did it in the Instagram post? Yeah, you probably would, hey? It took a while to figure it out that way. Not gonna lie. Okay, well, those were neat enough questions, I guess, for now. I guess we should move on to something normal, right? The thing about this is it's a little difficult to get going unless you have somebody that's actually got questions. You know, if you've got like a grade 10 student doing their homework, then they actually have questions. Or first year calculus having questions, you know, it makes a difference. What should we do? Grade 10, grade 11, pre-calc, more fancy ones. What do you guys want to do? Does anybody actually have homework that they want to do? I can tell that there's a few more viewers out now. We'll see. Let's do calculus while we wait. Okay. Limits. Might as well do limits, because that's probably what everybody's doing, getting taught right now. What is it? First few weeks, first term. They'd have a limit test right about now, right? Let's see. Find an equation of the tangent line to the standard parabola. At 0.1, 1. Well, we need the slope, right? We need the slope of the line. M. From the point PQ which will be what? X squared minus 1 over x minus 1. Because technically, the point is actually x and x squared, right? So, because this would be our y equals 2. So then our slope would be x squared minus 1 over x minus 1. And we can plug in values, but we need a second point, and we need to add 1. 1 minus 1 is 0, and we can't divide by 0. So, what do? We got to take a limit as x approaches 1, because that's our point. That's the point we're going for. Of x squared minus 1 over x minus 1. Well, we notice that x minus 1 times x plus 1 is x squared. So we'll take that limit. And then x minus 1 cancels out. And we get limit as x approaches 1 of x plus 1, which equals 1 plus 1, which equals 2. That's our slope. Now we need the equation. What's the equation of a line? The slope-intercept form. What is it? Y minus y0 equals m times x minus x0. I think that's it. Looks about right to me. So then we'd have y minus 1 equal to what are 2 x minus 1 from our point. And then what do we get? Y equals to 2x minus 2 plus 1. Y equals 2x y minus 1. And there we go. That's our equation. Interesting. There's a velocity problem. Let's solve some of these weird tank problems. So a tank holds 1,000 gallons. Now, which drains from the bottom of the tank in half an hour. Values of the table show the volume of the water remaining in the tank in gallons after t minutes. So, t min. I know, imperial system. We could just say it's liters. That would be better. Textbooks these days, right? North America. Worst way to deal with systems. 5, 10, 15, 20, 25, and 30. So the way they have the numbers written down is 694, 444, 250, 111, 28, and 0. Because it drains in half an hour. A. If P is the point 15, 250, On the graph of V, find the slopes of the secant lines with t equals 5, 10, 20, 25, and 30. Find slopes. Secant lines with t equals 5, 10, 20, 25, and 30. Well, this looks like just a bunch of calculator work to me. I don't know about you. No, it is just a bunch of calculator work. This whole section is. It literally says calculators. I don't really care about calculators. Not really interested in guessing questions or calculator work. Well, whatever. PQ. So when t is 5, v is 694. So 694 minus 250 over 5 minus 15, right? That's what we're doing. Alright, I'll type it in a calculator. We'll just do the first one because that seems a little tedious. Good enough. Screw calculator work. I don't think we even did that section in our school. Okay, better. Sketching, determine the infinite limit. Use a table of values to estimate. Well, let's just determine limits. Limit. X approaches -3 from the positive side of x plus 2 over x plus 3. From the positive side of -3. If that was the case, What do we get? Hmm? 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 Plus infinity or minus infinity? Dude, so much better all of a sudden. No more dropped frames. Delay doesn't even seem that bad. I wonder though. You tell me. I'm gonna flip through some stuff for a second. I want like an actual list of things to do that isn't tedious. Okay, well, -3 plus 2. As it approaches, this is going to be a negative on top, right? And 3 is bigger, so this is a positive on the bottom as it approaches. So we approach negative infinity. I don't know, man. I'm gonna have to figure out something. I'm gonna go think about some stuff. I'll be I don't know if I'll be back yet, but I'll talk to you later.